After the geometrical interpretation, now we'll start with some properties of indefinite integrals. In this section, we shall derive some properties. The first one, the process of differentiation and integration are inverses of each other in the sense of the following results. Now, as we know that integration and differentiation both are the inverses of each other. So, if we'll take any function f which is differentiable as well as integrable, so derivative with respect to x of the integration of f of x dx is nothing but the function itself. Okay, and integration of derivative of the function x with respect to x is equal to the function itself plus any constant, where c is any arbitrary constant. Okay, now we'll see the proof for this first property. Let f be any antiderivative of f, that is d by dx. If f is antiderivative of f, then the derivative of this function will be the f. Okay, so d by dx of capital F of x is equal to small f of x. Understood? So if this is the antiderivative, so can we write this as integration of f of x dx is nothing but capital F of x plus any constant. Understood? So can we take derivative of the above now? Now differentiate on both the sides. What will get? D by dx of integration of f of x dx is equal to d by dx of this bracket capital F of x plus c. Okay, now this is equal to derivative of capital F of x is nothing but small f of x. As we have seen, derivative of constant will be the 0. This is nothing but f of x. So what we got? The first one, d by dx of integral fx dx equals to f of x. Okay, so here we can write d by dx of integration of f of x dx is nothing but f of x. Understood? Now we know that f dash of x is equal to d by dx of f of x. Okay, now if we'll take antiderivative of this, that means the integration on both the sides, what we will get? Integration of f dash x dx is equal to, integration will be cancelled with this derivative d by dx sign, so it is nothing but small f of x plus c. So here we have proved with the second part of the property. Understood? Okay. Now the second property is two indefinite integrals with the same the same derivative with the same derivative lead to the same family, lead to the same family of curves, same family of curves, and so they are equivalent, and so they are equivalent. We'll see the proof. What is the second property? Two indefinite integrals with the same derivative lead to the same family of curves, and so they are equivalent. In the proof, we'll consider, let f and g be two functions such that d by dx of the integration f of x dx is equal to d by dx of the integration g of x dx, or you can write this as a d by dx of integration of f of x dx minus integration of g of x dx equal to 0. We can use here the property of the differentiation. Okay, if we'll apply differentiation over this, we'll get the previous one. Okay, now hence we know that derivative of the constant term is 0. So if the derivative of this part is 0, can we consider this term as a constant term? Okay, so we'll consider, hence integration f of x dx minus integration of g of x dx is equal to c. C is any real number, because we know that derivative of the constant number is 0 where c is any real number. Okay, that's why we have considered here c as a from set of real numbers. So can we rewrite this as a integration of f of x dx is equal to integration of g of x dx plus c. Okay, so the families of curves, like we can write as the integration of f of x dx plus c, or we can write plus c1. c1 belongs to set of real numbers. Okay, and integration of g of x dx plus c2, where c2 belongs to set of real numbers, are identical, are identical. Okay, so it is very easy. Just what is given we will write that, then we'll take the derivative of this part will be 0, this part will consider as a constant, then we'll shift this integration of gx to right side, and what we'll get, so if integration of fx equals to integration of gx we are getting plus any constant, so the families of these curves are identical. Therefore, if these families are identical, so can we write this integration fx dx is equal to integration of gx dx? So both are equivalent. Equal we cannot say, but we can say equivalent, because because we can add here any constant. Okay, so in this case, integration of f of x dx and integration of g of x dx are equivalent. Getting? Now we'll take one note on the second property, that the equivalence of the families, the equivalence of the families integration of f of x dx plus c1, where c1 is from set of real numbers, and integration of g of x dx plus c2 from set of real numbers is customarily expressed by writing integration of f of x dx is equal to integration of g of x dx without mentioning the parameter. Without mentioning the parameter. Okay.